Hi everybody. This video is just kind of set aside to maybe, now that you've had some practice working your way through dealing with some limits and addressing some curves approaching asymptotes, maybe we can knock off one big idea. And one of those significant ideas is the concept, or I guess the practicality, of crossing an asymptote. So, as we started kind of growing or being exposed to asymptotes, we have this definition that an asymptote is a line that a curve can approach but not touch. And then we kind of are like beholden to that definition. And so any opportunity then where you go like, yeah, but that curve crosses or touches an asymptote, that cannot be correct. And I want to make sure that we can maybe step that back a little bit. So let's take a look at this scenario. And really what we're going to talk about is the idea of crossing or like touching, intersecting asymptotes. So let's address the first case in red, vertical. We were exposed to going through and addressing how do we find vertical asymptotes because a function was undefined. And specifically, it was undefined by having a non-zero divided by 0. So if we had a fully simplified fraction and we were able to make that undefined by having a divide by 0, then that represented an asymptote. Okay, it's important for us to recognize then that there is no way to cross a vertical asymptote. Because in order to cross a vertical asymptote, our function would have to exist there. That is, it would have to, if we subbed in the x value of that asymptote, be able to generate a point, a value. And by definition, we can't. So you can never cross a vertical asymptote. However, I want us to take a look at how we found horizontal asymptotes. Notice that what we examined was not whether a function was undefined or not, whether we could arrive at a y value or not, but rather we examined the limit as we went off forever and ever in both directions. So, a couple things out of that. Like, it's possible for a lot of functions to not have certain y values. Like, you get introduced to your parabola in grade 10. All of these y values that are negative, your base parabola will never equal. That doesn't mean that there's an asymptote down there. It means that that y value isn't possible as an output, regardless of what you sub in for x. So, just because a y value doesn't arise doesn't mean asymptote. That what we see in green was us examining, well, what is the trend in the curve as we go forever in both directions? So, if we have huge values, like we're imagining subbing in infinitely larger values to the point where we never stop. So when we say that we're talking about for huge x values, then but that doesn't mean that it has to be true for small x values. Then the next question that you want to come to with that is probably like, yeah, but define for me, like what's big, what's small, and I'm going to tell you I can't do that. Like when we have, as x approaches infinity, like maybe 1 million small. Like 1 billion could be small. We're talking about going on forever in a certain direction. So it is possible to cross horizontal asymptotes. Like our function could have that y value as an output. It's just that in its extremes, it tends to approach a different value. So what I want to do is I just want to go through a scenario where maybe we can see how the curve crosses there and what it might look like. Okay, let's take a look at an example. What you see on the screen is me just putting down an awful lot of algebra. But really what I want us to do is focus in on the picture. I've put down the algebra to just justify some stuff for anybody who wants to look and see and make sure that I'm not trying to gloss them over with something. But I want you to look at all your tiny arrows to look at your nature. Okay, let's look to the left of x equals -4. I think it makes sense for us to be able to connect those graphs. Sorry, and I shouldn't say graphs, but to connect those two portions. Like that is, it makes sense that our curve would do something like this. If I jump over to the right side of x equals 0, well then it makes sense that our curve could do something like this. However, if you look in between your two vertical asymptotes, then you start to look and go like, okay, but the way my nature goes, if I'm going to go down in this direction and up in this direction, then the only way that that could happen is like if my curve crosses and we do something like that. And then we start to go, but wait a second, no, that shouldn't exist, like, because now that can't happen. And I need us to see that, yeah, that can happen. That what our blue says is forever to the left or forever to the right, we approach a y value of 1. But it doesn't talk about in between our forevers. So it could be possible that has an output of 1. Okay, so what I want to do then is I want to just give us an option. Something that if we feel, and you're okay to feel that way, that it's a unique situation, not unique, a more rare situation, a rarer situation to cross an asymptote than not, then what can we do to just check that? So let's take a look at this graph. I'm just going to get rid of all my algebra. So what we see is then our picture up on the top. We have our function. And what I want to zero in on is the fact that the asymptote was y equals 1. So if I ever want to check, like, does my curve cross? Then what I can do is I can just see, is there anywhere on that green curve that has a y value of 1? So I could sub in a 1 into my function for my y value, and now I can just solve that equation for x. So if I multiply out my x squared plus 4x, then 1 times x squared plus 4x is x squared plus 4x. Now, I go to solve that equation, and you notice that your x squareds cancel out. And I'll be honest with you, I don't even need to go further. That when I take a look at that, I can see I'm going to get a solution. Now, I could actually solve it and see that that's my graph. And so maybe proportionally, my green isn't the best graph. That if I was to cross, I should be crossing it like -3/4 somewhere here. So maybe I'm getting a little closer to this asymptote early, and I'm not quite there on the other one. Something like that. But that just gives us an idea of how we can cross our asymptote and what it looks like with the ability to check. So, again, when working through vertical and horizontal asymptotes, we can understand why we don't ever hit a vertical asymptote, the undefined nature of our curve. However, we're not that thrown anymore, that it is possible. If I can add in one more situation, can I just get everybody to look at the far right side of the graph? Because we may end up getting a case where our curve does something like this, where we actually cross the asymptote and then approach it from above. So all of these options open some things up, but you have the ability to always check it if necessary. Okay, I hope that helps, gives a little deeper understanding to some stuff. Your job, just jump back in and keep plugging through that practice. Okay, good luck.